Hello and welcome to this video. So the last video we went from chemical symbols to words, and now we're going to do just the opposite, and we're going to go from words to the symbols. So again, you need your periodic table out in front of you, and you need your yellow sheet. So those are two things that are going to be very, very important. You've got to keep handy. So again, we're going to watch for these key words. And again, remember when we talk about oxygen or diatomics, we're going to need to be sure that we do the O2. Okay, so on your sheet, and I'll go ahead and zoom in here just a little bit so you can see on mine, but yeah, maybe just a little bit better. There we go. Okay, so we have solid iron, so that is going to be Fe, solid. Now when you're writing this also, you want to leave space because you do need to balance this also. Okay, because it says a balanced chemical equation. So that is going to react with oxygen, and we know oxygen is O2 and it's a gas. It is then going to form, okay, iron 3 oxide. So iron, and again, if you need to, remember iron, it tells us is a +3. Oxygen, remember, is a -2. So in this case, if you do the crisscross method, Fe, okay, 2O3. Okay, now then, from this point, again, you're going to need to balance. So if you need to come over, remember how we did our count, and iron has 1, oxygen has 2, iron has 2, oxygen has 3. And so it looks to me like in this case, if we double the iron, that'll be fine, but that's not going to fix the oxygen. And if I change the oxygen here, that's going to change it there, but it also changes the iron. So I'm probably going to want to start with my oxygen first. So maybe I want to put a 2 out in front of this one. That's going to make my oxygen be 6. I'm going to put a 3 out in front of this one, which makes my oxygen 6. Okay, and now my oxygens are balanced, and now it's pretty easy for me to put a 2 out in front of the iron. So don't forget, you must balance these also. So a balanced chemical reaction. Okay, this one, nitric acid. Nitric acid was not one of the ones that I put on your sheet, but nitric acid is HNO3, again, because if you look at it, whoops, let me get an H, NO3, okay, nitric acid. It's going to react with, and we've got lithium hydroxide, so LiOH. Now, you guys need to check these. So you're going to check your lithium and your hydroxide. You're going to pull those from your periodic table. Periodic table yellow sheet. You're going to look up that lithium is a +1. Hydroxide is a -1. So we don't need any subscripts. Okay. And it's going to form lithium nitrate, NO3. Okay. So again, go to your periodic table. Lithium again is a +1, and nitrate on your yellow sheet's a -1. So we have LiNO3, and it doesn't say aqueous or anything like that, does it? So there's nothing here that's going to tell me, although in this case this would need to be aqueous. This is going to be a liquid. You don't know that, so I understand that. And this would also be aqueous. Okay, nitric acid would be 100% just a liquid on there, and then these two would be aqueous, and then it is going to do liquid water. So water is actually the only one they told you a liquid on, and so it would be acceptable not to put these because they didn't tell you. Okay, Now again, you're going to need to go in and balance. So I'm not going to take the time to balance those. Okay. Again, just like what we did on the last page, I'm going to skip number 3 for right now. We're going to come back and talk about those because this is talking again about those organic compounds that we mentioned earlier that we have not talked about how to name. Okay? And we'll just do a lesson on those probably one day in class. Okay? So we're going to go on to number 4. It says iron 3 nitrate, and it does say a solution. That's going to mean it's aqueous. Okay? So I'm going to have iron 2, nitrate, NO3, it's a 1 minus. So that means I'm going to need 2 nitrates. Okay, and again it says solution, so they're telling me it's aqueous. Plus a sodium chloride solution, so again that's going to be aqueous, sodium, Na. Chloride, Cl, plus and minus. Okay, and so we don't need any subscripts. Okay, and they're mixed and a precipitate forms. Okay, and remember that precipitate, what that meant with our evidence is that's those solid chunks. Remember we said we'll float out of it. So what they're telling you is, let's see, and a precipitate forms. They don't tell you what it is, okay? At this point, they just tell us that a solid forms, okay? And we don't know what it is, okay? So right now, translating, that's all you know, okay? So we're going to stop right there. And again, we'll come back and we'll finish this out. So don't panic. We'll finish it out and I'll show you what actually forms there, okay? Okay, our next one. Zinc carbonate, and this says it's going to decompose. So we have zinc, we have carbonate. Carbonate's a minus 2. Zinc is a plus 2. Guys, you check me on those. I don't have a yellow sheet and I don't have a periodic table in front of me, so I'm pulling these from knowledge. So please check me and make sure I'm not messing up. So we have zinc carbonate. It doesn't say whether it's aqueous or not, so we're just going to leave it. And again, you can't balance number 4, back up to that, because they didn't tell you yet what it is. It's going to form zinc oxide. So zinc and oxygen. Now this is not O2 because it's not oxygen gas, so it's just zinc and oxygen. Again, zinc is 2, oxygen's a 1, or a negative 2. And carbon dioxide gas. So that they do tell you. Okay, so they didn't tell us what these are, so we're not going to put anything there. Again, you need to go back in and balance. Okay, let's try the next one. Hydrochloric, that's supposed to be acid, not, I don't know, aid. A-C-I-D, how about that? Hydrochloric acid. Remember I gave you that on the front page, HCl. It's going to react with sodium hydroxide. Sodium hydroxide. Okay, look those up. So NaOH to form a salt. Now we don't know what the salt is, guys. Do not assume it's NaCl. Okay, do not assume it's NaCl. A salt is anything that is ionic bonded. Okay, so just because it says a salt. Now, we can determine what salt it is, because if I look in my equation, I do have sodium and I do have chloride. So it is the actual salt, table salt, NaCl. Okay, but just because it says a salt does not mean that it would necessarily have to be that. In this case, it is. Okay, and liquid water. Okay. So again, they don't give us anything else. We can kind of come back in and talk about these as we go, but you only have to translate what they actually tell you. So you can go ahead and balance this one out. You can balance 5 out. You can balance 2 out. Okay, again, we skipped number 3 for now, and number 4, at this point, we don't know what this is, and I'll show you, because when we come back, one of the things that we're going to be doing is you are going to have to know how to tell me what it makes out here. So that is coming down the line as a step. Okay, so that is your page 23. We're going to go on to the next page as far as what your homework assignment is. Okay, so you are on page 25 for your homework, and you are going to do the same thing here on these problems. Now, for sure, you must get through 1 through 6 today. If you don't make it through 1 through 6, you need to finish that. But if you finish 1 through 6, then go ahead and continue on 12, because you should really have time on this, I think, to be able to do that. But again, I want you to get through 1 through 6 minimum, and if you can, continue the others. Again, when you look at this, just look what it says. It says sodium. That's just the element. It's going to combine with chlorine. Now, don't forget, chlorine is your diatomic, and then it's going to produce sodium chloride. Okay, it doesn't give you